LeetCode 29, divide two integers. Solution by Michael Elliott. This is an easy solution. Given two integers, dividend and divisor, divide divisor into dividend. The result must be a 32-bit signed int. It means we truncate the decimal. So 10 divided by 3 will be 3. Dividend is 10, divisor is 3. 10 divided by 3 will result 3. When dividing numbers, if the signs are the same, the result is positive. A negative divided by a negative is a positive. Positive divided by a positive is a positive. When the signs are different, then the result is negative. We start the algorithm in strict mode as usual, and we get the sign of each operand, so the dividend and the divisor. Make sure that they're the same. A quick note on the math.sign method. It returns actually one of 5 values. -1 means the number is negative. 1 means the number is positive. 0 means the number was 0. -0 means the number was -0. And NaN means that it was not a number at all. Who would have imagined that math.sign would be so complicated? But there you have it. Fun little factoid of the day, JavaScript trivia, math.sign. So once we've determined that whether or not they are the same or not, we can assign that to the result of is negative. And if they're not the same, then is negative will be true. We then proceed to do our operation in positive. So assuming that they are all positive numbers, dividend and divisor are both positive, do that by getting the math.abs method, get the absolute value, to get rid of the minus sign off of both operands, if there is one. We start out by declaring the return value is 0, and what we're going to do for our strategy is to minimize the number of iterations in the loop. If we are given a loop that has 1,000,000 iterations, that will take time. And the value of this is, remember, we can have, it's going to be an assigned 32-bit int, assigned 32-bit int. So that could be a very large number. And in order to make that more efficient, well, I think if we divide, how many times does 1 go into 1,000,000? Well, does 1 go into 1,000,000 once? Yes, and then we can subtract 1, and then we have 999,999, and then we can do 1 into that, which gives us 999,998, 1 into that, 999,997, and that would be 1,000,000 iterations. That would take far too long. It would be slow, non-performant. Speed it up by doubling, by trying to double. See, well, 1 goes into 1,000,000. Well, okay, it does. What about 1 plus 1? Will that go into 1,000,000? Yes. And what about the result of that plus that? So now we're dealing with that. That's a variable. So 1 plus 1 is going to be 2, right? 2 goes into 1,000,000. What about 2 plus 2? That goes into 1,000,000. And so that would be 4. 4 plus 4, yes. 8 plus 8. So now we've already reached 8 with 1 plus 1, 2 plus 2, 4 plus 4. 3 iterations instead of 8. And this goes exponentially. So it goes much faster. We have far fewer iterations. And we can see that the strategy for doing this is going to be done in a loop. Right? 1 plus 1, and then 2 plus 2, and then 4 plus 4, and we can just iterate over that loop. So let's get into it now. We're going to have an outer loop. While the divisor is less than the dividend, then we're going to assign value to be divisor. Value is going to be our that, when I was referring to that in the description of the algorithm. So value is the divisor. And in our example, I'm going to just use 13 for the dividend and 2 for the divisor. So value is the divisor, and that's going to be 2 every time we're in the outer loop. And multiple is going to be 1. So now we create an inner loop to add that value onto itself, and then check how many times we added it onto itself as our multiple. And that means how many times it's gone into it. So for example, 1 plus 1 is 2. 2 plus 2 is 4. So our multiple from 1 plus 1 would go from 1, the multiple is 1, to 2. 2 plus 2 being 4, and then that would double as well. So then that would be 4. That would only be in the case if the value was 1, but still the multiple is always going to double from 2 to 4 to 8, 16, and so on. Well, value plus value is less than the dividend. Okay, so we're going to be checking this and then modifying the dividend potentially outside of this loop. But we're going to see how many times we can get the doubled values into dividend and then go back and see, like, let's say if we get a number, we get this 13, we get 2 into 13. How many times will 2 go into 13? We get 2. Let's just step through it. Value plus value. Well, value is 2. Less than 13. Yes. So value is now going to be 2. 4. Value plus value is going to be 4. Multiple is going to be equal to 2. Multiple is going to be equal to 2. So, because 1 plus 1 is going to be 2. And then we're going to continue on this. 2 plus 2 was 4, and now we have 4. Value is 4, remember, because we incremented it here. 4 plus 4 is 8. That's less than dividend 2, and dividend is 13. So now value is going to be assigned to 8. It's going to be plus equals. We're going to reassign it there. Now value is 8. Multiple is now going to be equal to what it was before, doubled, 4. Okay, so now value is 8. 8 plus 8 is 16. Less than 13? No. So we're done with the inner loop for now. We'll exit that inner loop. We go into the statements after that. Dividend, we subtract value from dividend. What was value? Value was 8. Dividend is 13. So now dividend is 5 from 13 minus 8. Ret is now going to be equal to incrementing that by multiple. Multiple is 4. So ret is now 0 plus 4 is 4. Okay, now we're done with this iteration of the loop. Now we go back up to our loop terminal condition. Is divisor less than dividend? Divisor is 2. Dividend is 8 minus 13 was 5. Down here we got 5. So we're going to reset the value to be 2, and multiple is 1 again. We're going to try again to see if we can double up that 2. And that's how that works. We've got the remainder of 5, but 2 still might go into that remainder multiple times. And that's why we have this nested loop with the outer loop and the nested loop. So 2 plus 2 is 4. That's less than 5. Now we're going to assign that to value. Value is now going to be 4. Multiple is now going to be 2 instead of 1. So dividend is going to be, after that, we're going to check to see if this loop terminal condition. 2 plus 2 is 4. 4 plus 4 is 8. Is that less than 5? No. We terminate that loop, and now we're done with that loop. So now we go to check to see if dividend minus value was 4. 5 minus 4 is 1. Okay. Now that's what the new value for dividend. And now dividend is 1. And that's going to be our remainder, because we already know that 1 is less than 2. So we're not going to be able to divide 2 into 1 evenly anymore. So ret is going to plus equal multiple. That's multiple was 2, so 4 plus 2 is 6. Now we go back up to our loop terminal condition. Divisor is 2, dividend is 1. 2 is not less than 1, we're done. Less than or equal to 1, we're done. So now we have the ret is we're going to clamp this finally to a 32-bit signed integer. We have to consider that we're dealing with a negative number. So when we're dealing with a negative number, then the result is going to be at the lowest possible number it could be is 2 to the power of 31. But if it's a positive number, it's 2 to the power of negative 2 to the power of 31. A positive number, it's 2 to the power of 31 minus 1. So we're going to check to see if it's negative. If it is, we're going to say 2 to the power of 31. And if it's not negative, then we're going to subtract 1 from it. And then finally, we're going to add the sign to the front of it. So again, here, math.min, ret, whatever's smaller, when we did our math in positive numbers, the ret value, or 2 to the power of 31 minus, if it's negative, then 0, and if it's positive, we subtract 1. Now, we could have gotten fancy by doing type conversion, but I just found that this ternary operator was, although a little more verbose, it's clearer. That's how to solve this problem. Thanks for watching.